Okay, so are we ready? 'Cause we're gonna keep this part fairly brief and informal. Um, so um, this class is going to focus just on stringed instruments, and I was thinking about this as I was driving over here, is that we're really only going to focus on the plucked stringed instruments. I could have brought a violin for an example, but a lot of the principles that we're going to talk about, all of the principles that we're going to talk about are going to relate to bowed stringed instruments as well. So we'll get into that a little bit. So I'm going to start with this device that I brought in. It's a put this up here. This is a monochord, and it's just got a single string, and this happens to be a meter long, so it's a sort of a convenient unit. And I don't know who the first person was that made a monochord, but maybe the first person that ever studied the monochord was Pythagoras. And so you know, there's a lot of interesting things that we can learn about it. If you stretch the string and then get it to some reasonable tension, you pluck it. It makes a sound that you may not be able to hear back there, but you probably can hear it. But then if you hold your finger right at the halfway point, and you pluck it, the sound that it makes sounds like it's an octave higher, right? And if you hold your finger at a third of the way down, pluck it on this side, it sounds like an octave plus a fifth, right? And so there are all these, if we use integer ratios, 2 to 1, 3 to 2, 4 to 3, all these sorts of ratios, we can recover the intervals that Pythagoras first looked at, which correspond to musical intervals. But what I like to use this monochord for is to talk about why it is that when I pluck this, now that that's off, maybe you can hear it better. Maybe we should be shutting that off. When I pluck this, you can kind of hear that. You can kind of hear that too, right? But you can kind of hear that. But none of those are as resonant or as loud as the sound from a stringed instrument. Okay. And so it sort of illustrates what it's different about the guitar or any other plucked string instrument. That is what's different about that as compared to the monochord. What is controlling the loudness of the sound. And the idea is that you want a loud sound is due to the sound itself is the vibrations in the air. All right. So what here is causing the vibration? Well, it all comes from the string, right? And in a sense, if I built my ideal monochord, would be the string stretched as tight as this one is, or as tight as I can get it to stretch, and then no support essentially underneath it. Like, I don't want anything that looks at all like a soundboard, because if the sound was coming just from the string, right, not from any soundboard at all, that tiny string would have to push enough air to create the sound wave that we hear. And it turns out that the surface area of the string pushing directly on the air is just not large enough to cause a sound wave that's loud enough for us to perceive as an audible sound wave. So how then does the sound get loud enough? The vibration is obviously caused by the string itself, okay? But then how does it get loud enough so that we can hear it? Well, what happens is I pluck the string vibrates, okay? And then that vibration is transmitted into the bridge. So the string pushes on the bridge vibrates, the bridge then pushes the soundboard, and then the soundboard vibrates. And if you have a real stringed instrument, you would have not just the string vibrating, the bridge vibrating, the soundboard vibrating. The soundboard then pushes on the air inside in the box, all right? And so then that air inside vibrates. And if this was not a folk guitar, but if this was a classical guitar, the classical guitars are usually held away from the performer's body. So the classical guitar, the string vibrates, drives the bridge drives the top plate drives the sound or the air in the chamber, and then the combination of the air vibrating and coupling through the ribs can actually drive the back plate. So, classical guitar is a much more studied instrument, much more, richer for acoustics. But a folk guitar is usually held against the body, and so we don't usually consider the vibration of the back plate. But in all cases, we're looking at coupled oscillations, right? We're coupling the vibration of the string into the rest of the guitar. So I'm going to try to turn this down. That probably will do nothing, but we'll figure it out. But the point is that the surface area of the soundboard is much, much, much larger than the surface area of the string. So the soundboard is pushing a lot more air and causing that loud sound to be heard.